Thank you for joining me again today as we continue and kind of wrap up our discussion on stoichiometry. Today we're talking limiting reactants. And so we've done up until now, if we have one substance that reacts, how much can we make for a product in the end? But what if we have two substances? So today you're going to determine the limiting reactant in a chemical reaction. What is the limiting reactant? You're going to tell me how much product we can make, and you'll find the amount of excess reactant left over when the reaction is all said and done. So to get started, I'm a big grilled cheese fan. So everybody knows if you want to make grilled cheese, you need 2 slices of bread and 1 piece of cheese to make a sandwich. So if I had 24 slices of bread and 14 slices of cheese, how many grilled cheeses could I make? Well, because I need 2 slices of bread per sandwich, 24 divided by 2 means I can make 12 sandwiches with the bread, and I only need 1 slice of cheese, so I can make 14 with the cheese. So because of this, I can only make 12 grilled cheese sandwiches in this instance. My 2 extra slices of cheese are going to be no good as far as grilled cheese sandwiches go. Okay, and so same kind of situation. This time I have 3 loaves of bread. Each loaf contains 30 slices. And I have 3 pounds of cheese. Each pound is 32 slices. So, limiting ingredient. So if I have 3 loaves of bread with 30 slices each, I know that 3 times 30 is 90. And I need 2 slices of bread per sandwich, so 90 divided by 2 is 45 sandwiches. If I have 3 pounds of cheese, each pound is 32 slices of cheese. 3 times 32 is 96. I only need 1 slice of cheese for each sandwich. So in this case, I can only make 45 sandwiches because my limiting reactant is going to be my bread. The one left over is the other one, that's the cheese, and my excess. So because I have 96 slices of cheese to start with, I make 45 sandwiches that use 1 slice each. My excess cheese is going to be 51 slices. Okay, and this is what we're doing in chemistry. We're going to do this with compounds and elements instead of food. Okay, so starting here, if we know that nitrogen and hydrogen react to form ammonia, we have this is our chemical equation. I need 1 molecule of nitrogen, 3 molecules of hydrogen, and I can make 2 molecules of ammonia. So if I have 2 molecules of N2 and 3 molecules of H2, how much NH3 can I make? Well, we said if we had 1 of N2 and 3 of H2, we could make 2. So I have 2 of N2, but I have 3 of H2, those 3. So I'm only going to be able to make 2 ammonias because those 3 molecules of hydrogen is going to give me 6 hydrogen atoms. And each ammonia takes 3, and 2 times 3 is 6 atoms of hydrogen. Okay, so my limiting reactant here is going to be my hydrogen because I run out. Would more than 2 molecules of NH3 be formed? No. I don't have enough hydrogen to do so. I have excess ammonia, or excess nitrogen, sorry, but not excess hydrogen. I've run out. So in this one, only the hydrogen is completely used up. That's called our limiting reactant. Like the name implies, this limits or determines the amount of product that can be formed. And the reaction stops as soon as your limiting reactant is used up. On the opposite side, the reactant not completely used up is called the excess reactant because there's excess left over. So in this case, nitrogen was our excess reactant because we had some left. Okay. So here we know that 1 molecule of N2 reacts with 3 molecules of H2. We can make 2 molecules of NH3. Before that even happens, we can look and we know that our nitrogen to hydrogen ratio is 1 to 3. Okay? And so that's going to tell us right up front that if we have 2 molecules of N2 but only 3 molecules of H2, it's going to be used up because of our mole ratio. And so that's what we're going to work with here is our mole ratio in terms of limiting reactants. So we're going to do a lot with this. So here we go. We have sodium chloride can be prepared by the reaction of sodium metal with chlorine gas. So we have 2Na plus Cl2 yields 2NaCl. I'm going to rewrite that here because I'm going to work on what I'm going to call an ice table down below this, which is going to help you separate and keep things hopefully in order. So we know that we have 6.70 moles of sodium. And I know that I have 3.20 moles of chlorine. The question is, how much sodium chloride can I produce? I'm going to start with 0. So this is the I in ice is called initial. C stands for change, E stands for end. So initially I have 6.70 moles of sodium, I have 3.20 moles of chlorine. That's a parenthesis. My change. So if I use up all of my sodium, because sodium and sodium chloride have a 2:2 or 1:1 ratio, if I use up all of this, I'm going to make plus 6.70 moles of sodium chloride. On the flip side, if I have 3.20 moles of chlorine, because this is a 1:2 ratio, I'm going to have to double my 3.2 because I'm going from 1 mole of chlorine to 2 moles of sodium chloride. So 3.20 times 2 is 6.40 moles, which is actually smaller than the 6.7 moles. So because this is smaller, I'm going to use up all of the chlorine. So I know over here for my change in this one is going to be minus 3.20 moles. And because this is smaller, I'm going to cross this one off on this side so I don't use it. Now I have to figure out how much of this sodium am I going to use if I use up all the chlorine. So again, this is a 1:2 ratio. So 3.20 times 2 gets us to minus 6.40 moles. And then I'm going to take, so E is end. So initial change end. 6.70 minus 6.40 is 0.30 moles of sodium. 3.20 minus 3.20 is 0. And 0 plus 6.40 moles is 6.40 moles of sodium chloride. So our questions: what is the limiting reactant? Well, we determined that chlorine is my limiting reactant. So limiting reactant is going to be Cl2. How many moles of NaCl are produced? We said that was 6.40. And now I could ask you to go to grams, and we'll do that later. But for right now, we got 6.40 moles of sodium chloride. Okay, next slide. Same question. We know that we have 2Na is a solid plus Cl2 is a gas versus 2 NaCl solid. So we know chlorine is the limiting reactant, sodium is excess. How many grams of sodium will be left over? So on the last slide, we had sodium. We had 6.70 moles to start. We subtracted 6.4. We ended up with 0.30 moles left. So if I have 0.30 moles of Na, and I have to go to grams, I have to multiply that by that molar mass. The molar mass of sodium is 22.9898 per 1 mole. Oops. And if I multiply those two out, I get an answer that should be 6.90 grams of sodium left. 6.90 goes there. Okay, so this is what we're working with. This is kind of how we're doing things. Let's try another one. This time we have zinc and sulfur. So now instead of giving you moles, I gave you grams. We have 12.0 grams of zinc and 6.50 grams of sulfur. So my 12.0 grams of zinc and 6.50 grams of sulfur. I don't have any zinc sulfide to start with. But now for my I need to be in moles. So 12.0 grams of zinc divided by the molar mass, which is 65.4, is going to give me 0.183 moles of zinc. Sulfur, S8. So 6.50 divided by S8 is 256.56 grams per mole. If I divide those out, I get 0.0253 moles. 0.0253 moles. And then my zinc sulfide. So here we go. I need to balance this. So there's 8 there and 8 there because of my 8 sulfurs. So because zinc and zinc sulfide have an 8:8 or 1:1 ratio, I know that this would, my change here, would be plus 0.183 moles if I use up all the zinc. If I use up all of the sulfur, 0.0253 times 8 gives me 0.203 moles of zinc sulfide. And so this is actually bigger than the 0.183. So that means that my limiting reactant, because I only made 0.183 moles with the zinc, my limiting reactant is going to be zinc. My excess is going to be the other one, which is sulfur. Okay? So up to this point, we're good there. On the next slide, now how much excess will be left over? So we know that we started with 0.183 moles of zinc and 0.0253 moles of sulfur. I didn't have anything here. My change, because I used up all the zinc, it's the limiting reactant. I'm going to subtract 0.183 moles from there, and I'm going to add 0.183 moles here. So this is I, this is C, and my N value, this is going to be 0, this is going to be 0.183 moles, and then I just need to figure out my sulfur. So again, there were 8 moles of zinc for every 1 mole of sulfur. It produces 8 moles of zinc sulfide. So this is an 8-to-1 ratio. So I have to divide the 0.183 by 8. I'm going to get 0.0229 is what I'm going to subtract here. So it's going to be minus 0.0229. If I subtract 0.053 minus 0.0229, I get 0.0024 moles of sulfur. 0.0024 moles of sulfur left. This wants it in grams. So I'm going to take this 0.0024, multiply by the molar mass, which we said was 256.56 grams per mole. And that is going to give me 0.616 grams of sulfur remaining. And then product produced, so that's that. We'll do more of this, but that's how many grams I have left. Product produced, I'm going to take my 0.183 moles of zinc sulfide times the molar mass, which is 97.47. Multiply that out, and I get 17.8 grams produced. .8 grams of zinc sulfide produced. So this is how we do limiting reactants. It's kind of a lot, but this is how we do it. Okay? Let's do one more together. I'm going to give you one you can try on your own. So we have aluminum reacting with oxygen to produce aluminum oxide. So we have Al plus O2 produces Al2O3. Balancing this, we put a 2 here, we put a 4 here, and put a 3 in front of the O2. So we had 15.6 and 10.3 grams. And 0 here. I need moles. So moles of aluminum, 15.6 divided by, divided by the molar mass of aluminum, which is 26.98, I believe. You should get 0.578 moles. For aluminum, 10.3 divided by 32 is 0.322 moles. Okay, so now we got to convert both of these into aluminum oxide. So on the change, if I convert oxygen to aluminum oxide, I'm going to take 0.322 times 2 divided by 3. That's my ratio. If I do that, I'm going to get 0.215 moles here. I'm gonna put that on the left just because oxygen's on the right, or on the right side here. My aluminum 0.578. I'm gonna take it times 2 divided by 4, or divide this by 2. Your change for aluminum is going to be 0.289. So because 0.215 is smaller, that makes oxygen my limiting reactant. So limiting reactant is going to be O2 because it produced less, which means I'm going to use up all of it. So 0.322 is going to be subtracted. I'm going to get 0. If I take that number times 4 and divide it by 3, on this one, I'm going to subtract 0.429 moles. Subtract those out, and you should get 0.149 moles of aluminum remaining. And then again, we're not using this one, we're using 0.215 moles produced. So aluminum oxide formed. I have 0.215 moles. Multiply that by the molar mass, and you should get 21.9 grams. So aluminum oxide formed is 21.9 grams, and then excess left over. We have 0.149 moles. Take that times your molar mass, which we said was 26.98. And you should end up with 4.02 grams of Al left over at the end. So excess left over, we have 4.02 grams. Okay? All right, here's one for you. Heating together solids, ammonium chloride and calcium hydroxide can generate ammonia. Ammonia is NH3. Aqueous calcium chloride and liquid water are also formed. If a mixture of 33 grams of each ammonium chloride and calcium hydroxide are heated, how many grams of ammonia form? Question 1. Limiting reactant. Question 2. Which reactant remains in excess? Question 3. And how much? Question 4. These 4 questions I'd like you to answer on your own. I'll help you out with the chemical formula. So we have the reaction. NH4Cl plus CaOH2. They said it produces ammonia, NH3. Liquid calcium chloride, aqueous calcium chloride, and water. Okay, so step 1 is going to be to balance this and then work out the rest of the answers as you go. If you pause the video, I'll let you work that out. I'm going to give you the answers so you know if you did it right or not. So pause the video quick and then I'll get you your answers. Okay, answer-wise, I have 10.5 grams of ammonia produced. Limiting reactant for me was ammonium chloride. Active remains in excess is calcium hydroxide, and grams remaining is 10.1 grams. So work your answers through, see if you agree with me. If you don't, come see me, have a conversation, we'll figure it out. But that is what I got. Hopefully we match up there. All right, your last couple questions. What unit is used to determine the limiting reactants in a chemical reaction? Is it moles, grams, or particles? And then here's one more problem for you to try. If 5 grams of hydrogen, 5.0 grams of hydrogen react with 5.0 grams of oxygen, how much water is produced? So how much water is produced? Question 1. Limiting reactant. Question 2. And how much of the excess reactants left over? Question 3. Work through these, and thank you for joining me. I will see you again next time. For now, have a great rest of your day, and I'll see you later.